ठीक आहे डिपार्टमेंट लेवलचं ऑर्डर फक्त कोऑर्डिनेटर वरती टाका आणि बाकीचं जर आहेच की सेशन आहे.
Good morning to all. Shall we start?
Yes, sir. Good morning, sir.
51, 52. Okay. So, as we have discussed yesterday related to the various addressing modes. So, you just mention here before starting addressing modes and further assembly directives used in PIC microcontroller, like we used to say that content beyond syllabus. Okay, so just mention CBS, content beyond syllabus, as most of the times we take content beyond syllabus at the end of the chapter or unit, but here it is necessary to take first, then we move towards the instruction. So it is necessary to first discuss the addressing modes and various directives used for PIC 16F. Okay, so before writing heading, or in short, you mentioned that content beyond. Okay, so as we have discussed related to the immediate, direct and register addressing. So immediate addressing means direct values are mentioned with the letter of indication, that is L. L stands for literal values or literal numbers. Okay, constant numbers are added in the working register or ANDed with working register, or simply we say that the ALU operations with that particular fixed or constant number with the content of W register. Okay, so content of W register will be modified according to the operation, that is numerics used, which instruction is used, that is move, that is simply copied, add, addition will be there, and or whatever. Okay, so this is related to the immediate. After that we discuss related to the direct addressing and indirect addressing. So the bits IRP and RP0, RP1, if you heard this bit from a particular SFR, the SFR name is, कुठल्या SFR मध्ये बघितलं आपण हे बीट? आठवते का बघा? Hello. The bits used RP0, RP1 and IRP bit. एका SFR मध्ये मेन्शन केलेत ना आपण, to select the register banks directly, indirectly. कुठला SFR आहे, रजिस्टर कुठला आहे तो? Hello.
Status register.
Sure.
Yes, sir.
Okay. So here these bits are used in status register to indicate that which register bank is selected. So when we discuss related to the direct addressing, in that case 2 bits are there for selection of register bank, that is RP0 and RP1, and with the help of these 2 bits we are able to select the particular register bank, that is either bank 0, 1, 2 or 3. So each register bank having the maximum memory location is 256. Maximum memory location is 256. So each register bank starts from 00 and ended with 7F. Okay. And further, second register bank, that is bank 1, starts from 80H to FFH. So again, it will consist of 256 memory locations. So to identify these locations, if we consider the bits required, so in that case 256 is equal to 2 raised to n, suppose. So here total how many bits required? So if we consider the bits available for direct addressing, it is mentioned in the diagram that 0 to 6 from opcode. Okay, so these 6 bits along with RP0 and RP1, that is again 2. So 0 to 6 means 7 and next 2. Total 9 bits are there, 9 bits are available, and with the help of these 9 bits we are able to identify or detect or select specific register bank, that is 0, 1, 2 or bank 3 in case of direct addressing mode. So here we are able to directly access the content from the RAM locations with the help of RP0 and RP1 as individual bank is selected. Okay. And second method, okay, so in this case indirect addressing mode is there, where 0 to 7, that is 8 bits are there, and one selection bit for the register bank, that is IRP. So based on the status of IRP bit, whether IRP is equal to 0 or IRP is equal to 1, as we have seen in status register, when IRP is equal to 0, first two banks are selected, and when IRP is equal to 1, next two register banks are selected. Okay, so in this case total memory locations or total number of bits are again 9. So 0 to 7, 8 bits, and IRP is 9th bit. So total 9 bits are there in both cases, in direct addressing as well as in indirect addressing. So 0 to 7 plus 1, and here in case of direct 0 to 6 plus 2 bits, that is RP0 and RP1. So with the help of these 9 bits, we are able to fetch or access the data, whatever available, loaded, stored in the register bank of RAM locations, that is data memory. Okay, so description for this, it is mentioned here, that is either in case of direct or register indirect addressing mode. Okay, so just have you written these addressing modes or not?
No, sir.
Okay, so write down for addressing modes 3 basic types, and after that some examples. Write down. Don't put your roll numbers in chat box. I have already told you so many times. Completed or not?
No, sir. Completed.
Okay. So these are the basic types. After that, we will go for the direct and indirect in detail. See, in case of 8051, there are several types of addressing modes. Basically, 5 are there, and if we consider in detail, so subdivided, so total 8 to 9 addressing modes are there in case of 8051. But here, addressing modes are restricted up to these three only. So just go with this, that is direct, indirect, and in the diagram itself, it is showing that what will be the action or function performed by these two addressing modes, and the number of bits also used for accessing the memory locations. See, just draw it as fast as possible.
Completed, sir.
Okay, see, when we go for any method, either direct or indirect, you have to first select your addressing method, that is address accessing method, that is either making the activation of bits in status register, either go with IRP or you go with the RP bits. So after setting these bits, you are able to confirm that which method you are going to be prefer. Okay, so here selection is based on your setting done in the status register, and then you start with the your accessing the contents with the help of your required addressing method or feasible to you, which method is feasible to you. Okay, so write for some points related to that, that is example related to direct and indirect. Here in case of direct method, we will see that 8-bit data in the memory locations whose address is specified in the instruction, that is here MOV WF0x10. Here 10 is your memory location, and from that 10H we are able to fetch the content directly. Okay. Or second example, we see that the directly ports are mentioned. So as we have discussed that the ports are having their own address also. Okay. Each port carries their own address. If you seen that the RAM locations, that is various SFRs available in the RAMs, that is the register bank 0, 1, 2, that is trace registers are also there and file registers are also there. So based on these registers, we access port also. If we know the memory address of the given port, then we directly mention the port address, or here it is mentioned the port B, C or 30 like that. Okay. So according to that, again, we are able to fetch or access the contents from the respective ports. No problem. So directly by mentioning port name or by mentioning port address. And in case of indirect addressing method, here we are not identifying the specific register with the specific memory location. The registers are having their memory locations temporary, as we have mentioned, like R0, R1, R2, that is R0 40H, R2 30H, like that in case of 8051. So here also we will go with the different file registers, that is FSR 0 or any other names you have mentioned. Okay, so according to that, you first assign the particular memory location to that particular FSR, and then we are using that particular FSR in your instructions or further various instructions multiple times or single time. Like here mentioned that move WF INDF independent file register 2 or 3, a name itself, it is not as a fix. So for this instruction INDF 2 does not having the same memory location, same address for the next any of the instruction or for next time programming. Okay, it may change based on your requirement. So it is not fixed. Like if we consider the memory location allocated for W register, it is always fixed. Memory location allocated for port, any port, A, B, C, D, or status register, flag register. Okay, so these registers having their memory locations fixed and predefined. But in case of variable register, that is file registers, there is no predefined or fixed memory location for the various operations and multiple times. If we defining now and in the same program, it will remain same throughout your program and whatever the duration is there. But if we want to change, we are able to change, no problem. So this is the working strategy related to the indirect addressing modes. And in case of direct addressing, mostly we defining the fixed address or permanent address allocated for a specific SFRs, mostly SFRs. Completed?
No, sir. Completed, sir.
Okay, so after this we will go for the directives used for ALP programming in PIC microcontrollers. So similar to the assembly directives used in 8051 microcontroller for the assembly language programming, here also we will go with the various pseudo instructions or assembly directives used in PIC ALP programming. Okay, so generally assembly directives are not a part of instruction and they are not executed by the controllers. Okay, So assembly directives are used to specify similar to the instructions but not exactly instructions, and they are defined in ALP programming for converting that particular operation or function. We cannot directly say the instruction as it is not executed by an controller. It is executed by an assembler and converted it into the machine language. Okay. So ALPs are generally used for conversion of ALP into the machine language program, and it is also called as pseudo or dummy instruction, as we have seen or mentioned in first controller also, that is 8051. These are the dummy instructions or pseudo instructions, that is directly execution is not done by an controller. Here also this is the same case. PIC is directly not executing or completed this directives. We cannot say directly the instruction looks similar or function is similar to the instruction, but we cannot say the instruction. Okay. So these are the directives, and we are specifically defined for specific applications, like indicating starting of the program by ORG, indicating end of the program by end, indicating some constant number by EQU, like that. Okay. Here some additional directives are there: radix, list, set. Okay. So we will see one by one. So see ORG, that is, which is similar in operation with the first controller, that is 8051. When we use the ORG directive and specifying some number after the ORG letter, that is ORG, whatever it is, if it is 00, then your program will start from 00H memory location from the program memory. If it is mentioned like suppose 100H, 20H, 40H, 50H, so program will be starts from that particular memory location itself. Okay. And to define or specify these directives, some methods are there, or number systems we use or prefer. Based on that, you have to mention. Okay. So if it is your decimal number system, you have to mention the D. If it is hexadecimal, you have to mention the H for hexadecimal. If it is binary, then mention B and mention the binary bits. Okay, 0101 bits. Okay. So default number system used for this directive is hexadecimal, and you need not to mention the H, that is ORG 100H. It is not required, but if you mention, no problem. And if you mention in the decimal number system, that is ORG 100D, then assembler will convert that particular decimal number into the hexadecimal number. So it will convert it automatically. So you mention memory location as per your convenience, and assembler will automatically convert it into the hexadecimal number system, and it will execute according to that hexadecimal values. Okay. So this is related to the ORG instruction. So before going for next, you just complete this. See, similar operation is there in case of 8051 also. As I have mentioned, some additional directives are there that is available for PIC. Some basic or common directives are having same function, that is ORG and end. EQU also same function. So if you remember for any one controller, you are able to write for another controller also. So my request is that you at least remember or understood the common directives which are used for both controllers. So whenever question may be asked for 8051, we are able to write. And also while writing ALP programs, that is assembly language programs, there also it is necessary to use some directives like ORG end, and sometimes like EQU, or sometimes defining the list which specific series of controller we are using in case of PIC microcontroller. So after writing these 4 lines, you call me. I will simply change the next slide or move towards the next slide. The basic function of directive is simplify your program. This is the main motto or function of the pseudo instructions or assembly directives. And some guidelines are also mentioned. That is, after writing org, we will write the various instructions. So before writing org, we cannot start. If it is started, but it will start with the org first. And after end, assembler will not be able to execute the next instruction, that is further instructions after the end directives. So your program should be in between these two directives. And these are the mandatory directives for ALP programs. In both cases, controller 1 as well as controller 2. Okay, completed or not?
Yes, sir. Completed.
Okay, so we go for the first directive, that is org. Take down this. Till now, I will call your roll numbers. Roll number 1. Give me attendance. Roll number 1. Absent. 2.
Present, sir.
2.
Sir,
Roll
roll
number
number 1.
2.
Present, sir.
Okay. Okay. 3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6. 6. Absent. Okay. 7,
Yes, sir.
8, 8. Roll number 8. Absent. 9. 9. 9 is also absent. Okay. 10.
Present, sir.
11.
Present, sir.
12. 12. 13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17. 17. Absent. 18.
Present, sir. 17, present, sir.
17. Okay. 18.
Present, sir.
Present. 19.
Present, sir.
20.
Present.
21. 22.
Present.
23.
Present.
24.
Present.
25.
Present, sir.
26.
Present, sir.
27.
Present, sir.
28.
Present, sir.
29.
Present, sir.
30. 30.
Present.
Okay. If it is completed, tell me. We will move
Present.
further and
Present.
then we go for the next attendance. Have you completed this? Okay.
No, sir.
So roll call 31,
Present.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38, 38, 38. Savan Rushikesh ना बघा जॉईन आहेत पण अटेंडन्स आला हेच माहित नाही. I will simply remove him. Then we will see what happen. 38. रिमूव्ह केले आता बघू काय होतंय येतात का नंतर. तिथंच असतील मोबाईलच्या जवळ तर रिक्वेस्ट करायला पाहिजे. नसतील तर त्यांना कळणारच नाही रिमूव्ह केलंय तर. 39. 39.
sir.
देशमुख ऋषिकेश. ओके.
Present.
40. ओके. 40.
Present, sir.
41.
Present, sir.
41. Ajay.
Present, sir. Present, sir.
Okay. 42.
Present.
43. 44.
Present.
Pradeep. 45. Absent. 46. Mayur. 46. I think he is not present, huh? 47.
Present.
Okay. 48. Gopal, absent. 49.
Present, sir.
50.
Present, sir.
50. Okay. 51. 51. Absent. 52.
Yes, sir. Yes, sir.
Okay. 53. 53. More Rushikesh. 53. Absent. 54. 54, 55, 56,
Present, sir.
56,
Present.
okay, 57, 57, Patil, are you there? 57,
Yes, sir.
okay,
Yes, sir.
okay, Mark.
Yes, sir.
58, लावली तुमची अटेंडन्स पाटील, you are present, considered. 58,
सर दररोजचं झालं सर.
okay, असू दे, no problem. 58 absent.
Oh, sir,
59, 59, 59 पवार जॉईन झालेत बहुतेक लेक्चरला
सर 53.
से पहिले. 53, ओके. 59, 59 गायब झाले बघा. आहेत बघू दे, मी चेक करतो. प्रोबेबली असायला पाहिजेत. नाहीत, गायब. त्यांना सांगा अटेंडन्स चॅट बॉक्स मध्ये टाकल्यावर नंबर लागणार नाही. 59 absent. 60 absent. 61 गिरीधर. 61 absent आहेत का? 61 ओके absent. 62 किरण. 62 होते की प्रेझेंट. 62 absent. Okay, 63.
Yes, sir.
64 अक्षय. 64 जॉईन करून परत लेफ्ट झालेत बघा. 65 प्रथमेश. 65 गेला प्रथमेश. ओके absent, no issue. 66, 67,
Present, sir.
68,
Present, sir.
okay. Roll number 8, why you have not given attendance and now putting your roll number in chat box? Roll number 8, are you listening?
Present, sir.
अटेंडन्स का दिली नाहीये? ओके. 59 also. हे बघा 38 आय थिंक. 38 ला 69 सॉरी, हा क्षितिजा 69.
Yes,
Okay.
sir.
38 ला आपण रिमूव्ह केलंय. त्यांना अजून लक्षात आलेलं नाही की तुम्हाला रिमूव्ह केलंय. आपण परत जॉईन करायला पाहिजे लेक्चर. सी म्हणजे तुमची मेंटॅलिटी काय आहे की एकदा जॉईन केलं, चॅट बॉक्स मध्ये नंबर टाकला की आपली अटेंडन्स लागली, आपण तासभर इकडे तिकडे फिरून यायचं. ऑटोमॅटिक अटेंडन्स लागते. परत नेक्स्ट लेक्चरला परत ऍट द स्टार्ट ऑफ लेक्चर जॉईन करायचं, मार्क करायचे अटेंडन्स आणि निघून जायचं. निघून जायचं इन द सेन्स मोबाईल जवळ असेल पण इकडे तिकडे काहीतरी करत असणार आहे. लेट इट बी. रेंज प्रॉब्लेम काय असेल आता हे 5-7 मिनिटांमध्ये त्यांनी रिकव्हर करायला पाहिजे होतं की कळतंय ना की बाबा आपण मीटिंग मधून लेफ्ट झालोय, आपल्याला परत जॉईन करायला पाहिजे. नाही ओके. सो वी विल सी. हे कंप्लीट झाले का नाही?
झाले.
ओके, सांगायला सांगितलं होतं ना. नेक्स्ट घ्या डीबी घेऊया, नाहीतर त्याच्या अगोदर डायरेक्ट एंड घेऊया. अगोदर एंड घ्या. एंड सेकंड एंड डिरेक्टिव्ह म्हणजे बेसिक आणि मॅन्डेटरी मध्ये येईल एंड. सो एंड इंडिकेट्स दॅट एंड ऑफ असेंबली instructions. So after this directive further instructions will not be executed by an assembler. So end is the last directive or last pseudo instruction. After that, your assembler will do not go further for execution of your instructions. So whenever your all instructions are finished, completed, whatever the subroutines are there, sub functions are there, like delay and interrupt functions are there. So after that, that is at the last only you should mention the end directive. Okay, and here only mention END, either in small letters or in capital letters. So write for that end directive. End means end of assembly process or program. So no instruction after this directive will be executed. So write down end directive. You mention number 2, not necessary to mention here 5, as I have mentioned 5, but in your sequence it is second. So mention second, that is end. So after org, end we will consider. After that, next instructions we consider. So generally here we take the directives which are common first, that is common to the or same function with 8051, and similar function is applicable here for PIC microcontroller, so that you are familiar with the both. And if it is asked for any one of the controller, that is write the directives or describe directives available or used for PIC or for 8051. You are able to write the at least 3 to 4 directives, if we consider the one directive for 1 mark.
Completed, sir.
Okay. So we will stop here. Next lecture, we will see the remaining directives, and then further we will discuss related to the instructions. So thank you. Stop here.